In this video, we're going to focus on grade 11 style titrations, which are titrations that happen between a strong acid and a strong base. We're going to use these to review the concept of titration along with titration curves. So in grade 11, you saw strong acid and strong base titrations, and that's basically a reaction between a strong acid, as you can see here, and a strong base. And when that happens, you get water and salt. And so the idea is that you have a pH of that's greater than 7 for the base, pH that's less than 7 for the acid, and then after the reaction has happened, your pH is equal to 7. You have salt and water. Now, as we learned, not all salts are neutral, but in the case of a strong acid, strong base titrations, if you do the hydrolysis, you'll see that your sodium and your chloride are derived from strong acid, strong bases. So therefore, this is going to be a neutral salt. So let's take a look at how we monitor this type of titration on a graph. This over here is called a titration curve. This is a titration curve, and you monitor the pH of your titration as you go throughout. So let's start with when we have on our x-axis, we have volume of strong base added, and on our y-axis, we have our pH being monitored. So what we're essentially monitoring is the pH of whatever is in the flask. So suppose I fill the flask with some hydrochloric acid. I did that. I don't know its concentration, but I filled it with hydrochloric acid. And this is the substance I'm trying to figure the pH out, the concentration out for. So what I did is I put the acid in the flask and I started to measure the pH before base was added, and you can see that it's below 2, around 1, pH of 1. And as I add base, you can see that on the x-axis here, I'm adding base. You'll notice that the pH starts to go up. Slowly, but it does start to go up. And this makes sense because essentially your flask initially is going to be filled with, this is my poorly drawn flask here, with some H+. There's also OH in there, but it's mostly H+, because you have HCl. And as you start the titration, you're going to start to add some OH, and that OH is going to grab some H+, and you're going to make some H2O. But the idea is that as you add OH, you're going to reduce the amount of H+ in the flask, and so that is going to lead to an increase in your pH. Okay, but it starts to do that slowly because you have a lot of H+ in here. There's a lot of acid, and you're only adding the OH drop by drop or slowly. So it's a slow rise at the beginning. But then eventually you reach a point where all of a sudden there's this sharp rise that starts to happen. And that's because you're really close to having reacted all of your H+, all of your acid with the base, with the OH minus. And so it's very sensitive in this little region here where you have that sharp rise that's about to happen. And if you continue adding beyond this sharp rise, now your pH is really, really, really high, because at this point you've essentially neutralized all your acid, and now you're just adding more and more and more base. So it's just your base that's being measured there essentially. Now, what is your goal with this titration curve? Your goal is to get as close as possible to what's called the equivalence point. The equivalence point is the point where all your acid has reacted with all your base, in a stoichiometric sense. So your moles of H+ is going to be equal to your moles of OH. And that's essentially what you want to aim for, because that's when your reaction is technically complete. So once you've reached that point, when you figure out, okay, well, what volume is required to get to that point? So this is my equivalence point, and this is my volume required to get there. Once you figure out this volume, then you can use that volume in stoichiometry to figure out whatever your unknown acid was, or unknown concentration was. So again, we want to aim for this equivalence point. We don't want to be below it, because at that point, not all the acid is reacted. We don't want to be above it, because at that point, we've reacted all our acid and then we've added too much base, and so we're going to get the wrong answer. We want to be very close to this equivalence point. How do we know when we've reached the equivalence point? Well, we have to put an indicator in the flask. So don't forget, we also put an indicator in there. That'll change color close to the equivalence point. So you can use a variety of different indicators. So for example, here there's two indicators that are being used. There's phenolphthalein, and then here there's methyl red. And it doesn't really matter which one you use as long as the indicator changes color within the steep portion of this curve. Because within the steep portion, your volume doesn't change much and you're very close to your equivalence point. So as long as you're within the steep portion of the curve, then your indicator is a suitable indicator to use. And you want to make sure the color change is essentially as close as possible to that equivalence point. It might not be exactly on the equivalence point, but if it's within the steep portion, this vertical portion that I'm describing here, then you're close enough to the equivalence point. So the point where your indicator changes color, that's called the end point. It tells you when to stop your titration. It tells you that, hey, you're pretty close to your equivalence point. If you continue, you're just going to go above it, and now you're going to overshoot. So essentially, if you're kind of in this region here, this is called an overshoot. You've just added too much base at this point. You didn't listen to your indicator. So your indicator, when it changes color, it's called the end point. It's not exactly the equivalence point because the equivalence point is a specific point on your graph. It's just close enough to your equivalence point that the color change says, hey, you've observed a color change, stop the titration, you're close enough. The calculations you do now will get you a pretty good estimate of what the concentration of the acid is. So in this case here, let's say we're using phenolphthalein, we want to aim for a specific color change. So initially, our flask would be colorless, because when you're in acidic solutions, your phenolphthalein is colorless. There's no color to it. And as you add base, you'd want to aim for a color change that's more of a light pink. Because what happens is if you get a dark pink, it's dark pink from all the way here and then beyond. So you don't know if you're still in the steep portion of the curve or if you're beyond. And you might have added too much, and therefore you might not get the right answer for your concentration. So for phenolphthalein, for example, which is a common indicator that you often use in grade 11, you want to aim for the light pink color because that means you're pretty close to that equivalence point there. So depending on what indicator you choose, you might want to aim for different colors so that you don't get an overshoot and you overestimated how much base you need to neutralize your acid in the end. One more special unique feature about this titration curve here in particular is you'll notice that the equivalence point is a pH is equal to 7. So for strong acid, strong base titrations, you've reached the equivalence point when pH is equal to 7. So if I said you've reached equivalence point, that means you know your pH is 7. And that works for strong base, strong acid titrations because the salt that you have there is a neutral salt. That's why. But as we learn, not all salts are neutral. And so when we see grade 12 style titrations, the equivalence point may not be at 7. It may be a little bit higher. It may be a little bit higher or lower, depending on what type of weak acid, what type of acid you're using, or what type of base you're using, a weak acid versus a weak base. But in the case of the grade 11 style titrations, where we have strong acid, strong base, the equivalence point is always going to be a pH of 7. And you want to make sure you have an indicator that falls within this steep vertical region here, because again, there's very little change in volume, and so you're pretty close to your equivalence point. Doesn't have to be exactly on, but pretty close. So your indicator needs to have an endpoint that is close to the equivalence point, but not right on. So that was just a brief overview of the titration at the grade 11 style that you've seen before. With strong acids, strong bases. We briefly went over titration curves in some detail for strong acids, strong bases. In the next video, we're going to do a calculation of grade 11 style titration, just so you can see how it relates to everything we discussed in this video. And then after that, we'll take a look at some titration curves for grade 12 style titrations, where you're dealing with weak acid, strong base titrations, or strong acid, weak base titrations. And so we'll take a look at how the titration curves are different, which will lead into our lesson on calculations related to titrations in grade 12.